Hey everyone, this is John Kay. Just wanted to post a quick video on my latest experiment, which is called pulsing a coil with a cap pulsar. So the setup I've got here is a very large 81 strand coil, 81 strands of number 23 wire, and a Bedini large comparator. So this comparator is taking the energy from that solar panel out there, which is actually rated at 200 watts, but it's a very cloudy day, so I'm not getting a lot of energy off it. In fact, I am only pulling about 0.3 of an ampere out of it. Okay, so that's the Bedini comparator there. In that mess of tangled wires, you can see there's a 4-way bridge rectifier down there. Coil's a bit of a mess because this used to be hooked up to a solid state SG. What was running there, so I'm just using the same coil. The output of the comparator and the coil goes to this battery. It's a 50 amp hour 12 volt gel cell battery. It's load tested at about 43 amp hours at the moment. It's a pretty old battery, but it is coming back. So I actually took this down to 10.5 volts overnight, and I've just started recharging it. Okay, so you can see I've got this voltmeter here. We're dumping the comparator at 25 volts. You see it's doing it pretty slowly. Obviously in full sun this would be going a lot quicker, the more energy. I've got it hooked up to a scope. The scope is just hooked up to one spare strand of the coil just so I can monitor it, and I'll go into more detail about that soon. I wanted to show you over here I've got the old laptop hooked up to a battery voltage monitoring thing. I'll try and get in a bit closer, so about there. So it's only at 11:30. We actually started at about 11:28. How long ago? About 38 minutes ago. So you see it is charging up slowly, but what I wanted to point out is all those large spikes, that's kind of when the laptop's capturing the dump. It doesn't do it all the time because it's a pretty slow sample rate and it's a pretty fast pulse coming out of that comparator. So you can see it's slowly getting up there. Again, obviously with more sun that'll be going up quicker, but point of the demonstration, it's good to be able to show you that how this thing is working. Okay, we're going to have a look at the scope. So I'm going to pause this. I'm going to try and get 3 spikes up on here just to show you. So each one of these is when the comparator dumps. There's 1, there's 2, there's 3. Alright, so I'm just going to pause that there. This is really just to show you we're at 500 milliseconds per division. I'm just going to talk that over a bit. So you can see that's 500, almost 2.5 seconds per dump at this point, at 2.25 seconds. But what I did want to do is I'm going to try and zoom in on one of these guys, because I really want to show you what the waveform's doing. Okay. It might take a bit to capture it. There's one there to capture this because I've got to kind of pause it just as it dumps. Okay, so there's one there being able to capture. Right, so if we expand that out a little bit, we're now at 5 volts per division, 10 milliseconds. So you can see each pulse is around about 12 milliseconds per pulse. So this little up portion here, I'll get something to point this out. Okay. I want to point out this part here, okay, is as soon as the pulses. So what this is measuring is pretty much the voltage drop over the coil. Okay, so you can see when we charge the coil, which is the first part of the pulse, immediately it's dropping to about 10.2 volts. Now remembering we're dumping at 25 and the battery's at about 11.5, right? So theoretically there should be about 14 volts dumping over the coil. You can see that drops to about 10 straight away. Obviously we're not capturing all of it, but you can see what then happens is as the coil charges up, Okay, the voltage drop over the coil decreases to 0, and it's actually going below 0. It's going about 2 volts below 0. You can see this little bottom of the curve here. Then what happens is when that pulse stops, okay, so after the green light has finished blinking, if you want to, this is the coil discharging. Okay, so this is the radiant spike going here. You see the way this shows it, it's dumping, it's saying minus 20 volts. It's actually a lot higher than that, but it's just the scope can't really capture it well. So you can see the coil discharges, so you get that spike, which is going through the bridge rectifier and into the battery. Okay, you can also see it finishes spiking, and it actually goes a little bit above 0 as well, but I'm not sure why it does that, whether it's just the scope or not that's doing that. So that's pretty much the waveform you're looking at. Once again, we've got coil charging. Okay, as soon as the green light starts, or the start of the dump, coil charges here. Okay, I'm theorizing that once it gets to 0, the coil is fully saturated. I'm not really sure what goes below 0 here, or if it's just the scope not really measuring it correctly. It's a cheap Chinese scope. Okay, and then this is the coil discharging. Okay, now at both of these stages, the battery during this phase, during the first half of the dump, I suppose, or during the dump cycle, it's getting a current pulse as well. So as the voltage over the coil drops, it means the battery's actually getting more, if that makes sense. It's kind of like the inverse of this kind of drop. Okay. Then again, once that pulse finishes, the coil needs to discharge, and then it obviously flips and discharges through the full wave bridge rectifier and into the battery, and that's what charges the battery. So it's kind of like, it gets a current charge followed by a radiant pulse. Okay, this is exactly the same as what Peter Lindemann described in his setup at the conference not that long ago. Okay, so that's about all there is to show. I have another quick look at the battery. As I said, it's not going up. I previously had this running off this lab power supply where I could pretty much dial in the voltage and the current that I wanted to put out, and I had it running at about 3 amps, and it was pulsing a lot quicker, and obviously charging the battery a lot quicker as well. So there we go. Any questions, feel free to post them on the energyscienceforum.com website. You'll find the post there. Otherwise, leave a comment in the YouTube video. Like it if you want, subscribe, whatever. That's all. Thanks for watching. Cheers.